continue with the representative from Aristotle University. So, Mr. Makris, please.
Okay, so this section was about, we want to talk about energy efficiency and how we want to optimize our energy systems. ABB is talking about digitalization and adding sensors and monitoring systems, but what I want to talk about is how we could optimize our other aspects of the process. For example, how we can insert a circularity and sustainable development into our optimization process. So what I want to talk about here is how we can couple energy optimization with decarbonization, of course, with the sustainability pillars and how circularity comes to play into energy efficiency. And then we will see each energy system of the Neutron project specifically and try to see how we can optimize every system in terms of its sustainability pillars. So energy efficiency, of course, is the first pillar of decarbonization. The most green energy that we have is the energy that we do not use, basically. And we need to decrease the energy consumed globally in order for us to achieve decarbonization. As we can see here, along with clean electricity, of course, electrification of processes, clean fuels for transportation, carbon capture, the first pillar is energy efficiency. Until 2050, we count on reducing our energy consumption to up to 40%. So what I want to show here is that we don't only need sensors and digitalization to optimize our system. The social aspect plays a huge role in optimizing our processes. So for example, if we have social education and social involvement in our project, then we could increase the energy, we could decrease the energy consumed from the households, and then we can reduce the size of the proposed system that we have. This reduces the cost, reduces the carbon footprint of the initial installation, and also reduces the energy consumption itself into its household. And about circular economy, I think the circular model itself is a way to optimize the energy system in general. So reusing energy that was not used, was thrown away, having industrial symbiosis, for example, taking the output of a sector and having it as an input in another sector. So the most, let's say, the most simplistic form of sector coupling is the waste management and the energy production. So taking the waste and utilizing it as a source to produce energy. So if we take each, okay, so this is the proposed, let's say, overall Neutron energy systems. Here we can see we have the biogas that we're talking about in work package 2. We have the agrivoltaic system plus the grid module along with potential grid integration here. So we could provide electricity into the city of Kozani, and if we have the available organic waste streams of the city of Kozani, we can then produce biogas. And of course, this biogas will be turned into heat and electricity as well. I mean, I try to make the diagram as circular as possible because this is what we're trying to achieve, of course, here. So if we go and we go into every energy system in specific, what I want to show here is, of course, we can have a technical optimization in terms of the design. So for the agrivoltaic system, we need to see the number of the height that we will install the PV. We need to see the number of strings. We need to see the distance between the strings, so we will have the needed solar radiation for the plants, for the cultivation. We need to see which cultivation is optimal for the shadow that we will have between the PVs. And for the social aspect, what I wanted to showcase here is that if we want to optimize the potential of the overall system, then we need to have an energy community utilizing the cultivation below the agrivoltaics, because this is job vacancies, of course, in the local area, and this is also money given back to the people of city of Kozani or in every other city that we could utilize this sort of system. And to further increase the circularity of the whole system, we could utilize the residue, the crop residue of the agrivoltaic system into the biogas digester that we propose implementing. Moving on from the agri-PV system into the biogas production. So, okay, in terms of technical optimization in the design phase, what we could do to produce more biogas is study or maybe assess the carbon to nitrogen ratio from the available waste streams that we have. So we will have the most optimal production in every digester that we would design. In terms of social aspect now, this is a huge topic. If we take the organic fraction of the municipal waste and we assume that we want to utilize this type of waste for biogas production, then we know that the wrong throwing, so throwing, for example, plastic into the bins that are said to have the organic waste inside, this contaminates the waste. And what happens there is that in most of cases, we cannot utilize this amount of waste for biogas production and even for compost. So unfortunately, this type of waste, in some cases, we can still utilize this by incineration plants, but we know that in Greece, we don't like burning waste. Maybe, I don't know if this is a good thing or a bad thing, but if we increase the social involvement and the social education, we can optimize the process of the waste stream utilization. So if we could maybe add some incentives to the people of Kozani or every city that they could throw the organic fraction and only the organic fraction, not throw the plastic and don't care about the process itself, then we can increase the potential production of the biogas from the organic fraction. So what I have here is what I wanted to show is to your right, you can see a picture from Kozani's organic household waste. The colorful things that you can see there are plastic bags. So the people of Kozani, they think that they're throwing away their organic waste, but they need to carry this organic waste somehow. So the plastic bags are being used for throwing away the organic fractions. So unfortunately, people have to go there and just rip the bag one by one so they could take the plastic out. And even then, we will have microplastics inside the organic waste. This cannot be utilized for biogas production or even for compost, at least for an efficient amount of compost. To your left, we have a biogas production plant that, if you can see here, we've got specific sectors. So this is a separation unit. The organic waste comes from the right, and then in terms of the volume of the plastic that the technology recognizes, it separates the organic waste. So the most clean, let's say, fraction is the one to the left, and the most polluted one is the one to the right. What is being done then is we take the clean fraction and we utilize it for biogas production, and then from the digester we take the waste and create compost. But the right fractions over here, you take them and in the specific plant, they incinerate them. So they create heat from incineration plants. But we know that in Greece, this is not being done yet. So if this was to be done in Greece, all these fractions here would just be thrown to the landfill, basically. And this is almost 40% of the percentage. This is a little bit outside of Bonn, and we know that people there have incentives for this amount of waste. So, for example, in this plant, people can go and give their yardage waste, so the yard waste, and they can take back some compost from that. So we have, even if we have incentives, even if we have informed people, we can see that we still have wrong throwing, and this decreases the efficiency of our system, decreases the optimization of our system. So what I want to showcase here is that the social aspect plays a huge role in optimizing our energy system, especially the biogas production. Now moving on to the district heating system and the green heat module. I mean, in terms of technical, I'm not the right person to say this, but I think we had a really fruitful discussion before about this. What I wanted to showcase here is the social aspect. Again, if we have informed citizens about what they will gain in, for example, increasing the energy efficiencies of their houses, so reducing, saving heat, saving energy in general to the households, the first outcome would be that they would reduce their bills, of course. But the second outcome would be that if we want to, let's say, install a system like the green heat module, the overall capex and the overall carbon footprint of the installation would be reduced. Because if we had a heat demand of, let's say, 10 units, and then we employed some energy savings into the households, for example, insulation or the windows and all that stuff, we could drop this unit down to, for example, 8. So then we would need to design a system for a reduced amount of heat demand. And yeah, if we want to continue into the circularity of the system of in the Neutron project, what we could discuss about here is that green heat module couples the two sectors. It's the energy production, the energy generation sector, and the heating demand from the households. So we have an extra demand. We can produce an extra demand for electricity that is not being used. When we say not being used, we mean that this amount of energy, this amount of electricity, as Daniel mentioned, could be dropped, the cost could be dropped into zero. So this is the same diagram as Daniel's. What we could see here is we have hours that the electricity can drop into zero. So with optimizing our system, optimizing the system and coupling the two sectors, we can basically increase the end user utilizing this electricity and buy the cheap electricity, turning it into heat demand and providing it to the households. This will not only decrease the cost for the households. So if we say that the current cost for the heat inside the household is 5 units, then we can decrease this into lower than 5. Okay, so in a nutshell, what we wanted to say here is that optimization can not only take place with digitalization, with sensors, with monitoring systems. We can optimize our whole process from the beginning, from the people, from the local, not only from the citizens, but from the local authorities as well. We need to have educated people that can help us into the process, because for example, the waste streams, the input that we have is from the people. And also, as we said, that the social involvement is really crucial for that. And what I wanted to mention is that the optimal, not every case, so every case has its optimal solution into the energy systems. So what we were trying to do is that we took into consideration the local aspects of Kozani in order for us to create this energy system that we see here. So it's the most optimal overall energy system for the city of Kozani and its local aspects. I think this is about it. Thank you very much. If you have any questions?
Thank you very much, Dimitris.